septillions, octillions, nonillions. It just keeps going forever and ever. We usually don't get to numbers quite that big on a daily basis, but the numbers go forever. Hi, I'm Math Dad.
I'm Science Mom, and in today's videos we are going to learn names for bigger numbers.
That's right, big numbers like millions, billions, trillions, and so on. We're going to be talking about the place value, so what each digit means in a number.
And decomposing numbers. When I think of decomposing, I think of rotting vegetables in the compost pile.
Okay, so those vegetables are breaking into smaller pieces as they decompose. Well, the numbers are the same way. They're composed of single digits, and we can break them apart. We can decompose them into smaller parts.
All right.
And we'll also be multiplying and dividing by 10, making sure we're comfortable with that part of place value.
But before we dive into those topics, we want to show you the answer to our warm-up problem, and I came up with a solution. Math Dad, look at this.
You did it, Science Mom.
So I did 6 minus 4, which equals 2.
Good.
Then 2 times 8 is 16. 16 minus 4 is 12. So I underlined with purple the 4 numbers that I used, and that's how I did it.
Nicely done. I'm actually going to rewrite your solution. Just a slightly different way. I like what you did. I want to present it using just the 4 numbers as an alternative here. So what we can do is 6 minus 4. Is that how we started?
Yes.
All right. So I'm grouping that in parentheses.
Very
and
nice.
now I'm going to multiply that number by 8, because that's what you did next.
That's right.
That gives us 16. And then all of that we subtract 4 from. And if we wanted, we could even throw an extra set of parentheses on there just to make it obvious, although the order of operations says that we should do multiplication first. But that does work out
To be 12. Very nice.
Well done. I actually saw a couple other solutions that I'll share. One of them was to do 6 times 4, which would be 24, and then let's just subtract 8, and then subtract 4 more. That works out to be 12.
Very nice.
And I saw yet another way. Let's see. If we do 6 times 4 times 4, all divided by 8.
6 times 4 times 4 is...
96?
96 divided by 8 is 12. Wow.
Indeed. So those were the ones that I saw and Science Mom came up with. My guess is that there are other ways of doing it.
And if you came up with a different one, just put it in on your worksheet.
Yeah, kudos to you.
And now it's time for big numbers. This number is enormous, and I bet you're going to ask me how to say this number. Am I right?
I'm going to ask you how to say that number.
Because I have no idea.
Right. Well, it's huge. Like if I ask you the number of breaths you've breathed in your lifetime, my guess is it's significantly smaller than this. So that's how big this number is. So let's see. How does this work? So the last three digits here, we got 881. We're probably pretty good at hundreds by this point, but then we get to the thousands. So I'm gonna write that out. Thousands.
So that's 335,000. That's what that green part is you underlined.
Okay, then we have the millions.
I know thousands and millions.
After millions comes billions. Okay, after billions, trillions.
Trillions. And then it's the next one I'm not quite sure about.
Ooh.
Is it quadrillions?
It is. It's quadrillions.
What's after quadrillions?
Quintillions.
Quintillions?
And then sextillions, sextillions, septillions, octillions, nonillions. It just keeps going forever and ever. We usually don't get to numbers quite that big on a daily basis, but the numbers go forever. There is no largest number. All right, so how do we say this number out loud? Well, we would say, I'm going to write it out. This is
5 quadrillion, 288 trillion, 917 billion, 843 million, 335,881.
Whoa. That's a big number. All right, how do we say this number? It's not as big as the last one.
And if you have the worksheet, this is a good point for you to pause the video and try to write it out yourself before you see Math Dad write it out. See if you can write out this number.
Okay, so we had our thousands, we've got our millions, and we've got our billions. So we would say this number as 83,243,765,432.
Nice.
So as long as we know these names for thousands, millions, billions, we just have to worry about our groups of three, and we can say the entire number.
83,243,765,432.
That's a big number.
It is. All right, Science Mom, look at all those numbers here. Ooh, and you notice something interesting near the middle of this number? 3 consecutive zeros. Ooh, what role will that play? Let's see. So I've got my colors selected here. Yellow,
Hundreds,
the thousands,
thousands, millions, billions, trillions, and quadrillions.
Awesome. I'm going to write those out just like you said. So that was the quadrillions, this was the trillions, this was the billions, the millions, the thousands,
and the hundreds.
You might call it the hundreds, you might just call it the ones. I'm not even sure what I would call those first
The
three.
first three.
But,
Okay.
all right. So to say this one out loud, we would say 626
Quadrillion,
quadrillion.
490 trillion. And then do we just skip billions? And
We
then
just skip
say
the billions because there's no.
156 million?
Very good.
Because there are 0 billions. And 712,154. That's
right.
another big number.
That is a big number. Could barely fit it on our screen here.
Ooh, decomposing.
All right, decomposing, and we're not talking about vegetables, Science Mom. So we have this number, 3,576. There are 4 digits there, the 3, the 5, the 7, and the 6, and each of them carries a distinct meaning because of its place. They don't all have the same value because of where they are placed.
So if we rearranged these numbers and instead we had 7, 6, 5, 3, that's a completely different number.
It is a completely different number. I agree. So I'm going to erase that, dispose of the evidence. All right.
It was a brilliant addition to your lesson, Math Dad.
Thank you for your brilliant addition, Science Mom. All right, 3,576. We can break this into a sum of individual parts. So that number 3...
That represents 3,000.
Agreed. So 3,000 plus...
500.
Ooh, 500, because the 5 was located in the hundreds place. Plus...
70.
And then what about the 6?
That's just a 6.
It is just a 6.
It's in the ones place.
That's right. So the number 3,576 could be viewed as a sum of these four numbers in a very natural way. We say that the 5 is in the hundreds place because it represents a 500. The 3 is in the thousands place because it represents a 3,000. So when someone says the word place value, that's what they're talking about.
This is what they're talking about.
Yeah, the location of each digit inside of a number and its actual numeric value.
And this is pretty important for all the other stuff that you understand in math, right?
Absolutely. You can't really understand the numbers without understanding the way
Place
that place value works. Science Mom, I'm handing over the pen. Can you handle the responsibility?
Oh, yes, I think I can.
All right. So we have 104,329.
And I want to decompose it. So
Decompose.
start with the 100,000. That's just telling us that there is one of the 100,000s.
Good.
And next we have a 0 here. That means that there are not any 10,000s.
Correct.
So I'm just not going to write anything. Or do you want me to write 0?
No, I like it. Skip right over it.
Skip right over it. 4 in that place right there means that there is a 4,000.
All right.
And then the 3 is in the hundreds place, so that means there is 300. And the 2 is in the tens place, so that means it's a 20. And then last but not least, we have our 9 in the ones place, which is a 9. So I can add these all together, and I will get the exact same number. If I add down... Whoops, but I put my comma in the wrong place. You didn't see
You
that.
snatched defeat from the jaws of victory there, Science Mom. You had it and you lost it.
Oh no.
All that was left was the celebration, and then the comma got misplaced. That's all right.
It was a very sneaky comma. It went where it wasn't supposed to.
But we're able to decompose a big number into a sum of individual parts, and only the first digit of each of those parts was not a 0. Everything else was a 0. All right. Multiplying a number by 10. I bet you remember how to do this, Science Mom.
I do remember how to do this.
457 times 10. How do we carry it out?
We just add a 0 onto the end. We move everything over, basically.
Exactly. Stick my comma in there. 457 times 10 is 4,570. Does that trick always work?
I think so. Yes.
Yes, it does. It's amazing. Multiplying by 10 is...
Super easy.
Yep, I can do that all day long. I was born for that. All right, well, what about dividing by 10, Science Mom?
Then we do the opposite. We're moving the place value the other direction.
Ooh, so 2,440 divided by 10?
We just lose the 0. It's 244.
That is correct. So multiplying by 10, we stick a 0 on the end. Dividing by 10, we remove the 0 from the end of the number.
What if the number doesn't have a 0 at the end?
Ooh, well then we're going to be getting into decimals, which we will indeed be getting into this semester, but maybe not so much today.
So today we just had a quick checklist of some topics to make sure that we were strong in those topics. And if we are we ready to dive into further videos?
We are.
What if one of these topics was tricky for us? Do you have any practice problems we can do?
Indeed. If the worksheet that's in the description has some practice problems, but Science Mom, we have finally made it to the part where you get to demonstrate that you learned what you learned today.
Oh.
Woohoo. So with the lesson's over, it's now time for you to demonstrate.
How do we say the following number?
How would we say that big number?
So, whoops. We have the hundreds here, the thousands, the millions, the billions, the trillions, the quadrillions. So I'm going to start with quadrillions. And I'm going to say it's
62 quadrillion. Good. 305 trillion. 956 billion. 411 million. And 42,000.
Nice.
62 quadrillion, 305 trillion, 956 billion, 411 million, 42,333.
Nicely done, Science Mom. Never make a mistake again on a big number, right?
I don't know about that.
Okay. Can you decompose this number 36,871 into a sum of parts?
Oh, you bet I can. Watch this. We have 30,000
Okay.
plus 6,000 plus 800 plus 70 plus 1.
Ho ho!
And I should move that plus sign down there. Doo-doo-doo.
Okay, so when we've done that, you're saying we would add down and it would give us the original number?
That's right.
Very nice. You've decomposed it into a sum of parts. Okay, multiply 5,892 by 10.
Oh, this one's easy. I'm going to take my number, 5,892. I'm going to add a 0 onto the end, and now I just need to count 1, 2, 3, put my comma in there. It's now 58,920.
That's right. And ideally, you would actually write out a full sentence each time you do one of these problems. So 5,892 times 10 is equal to that. And in theory, you should even put a period at the end, although that's kind of overkill. But now it reads like a sentence. It's a complete thought. The teacher doesn't have to guess what I meant when I wrote that number there.
I'm really curious, Math Dad. When you were doing math, do you put periods at the end of your equations?
I usually do, yes.
Wow.
Yep. All right, and then the last problem for today, divide 657,360 by 10.
657,360 divided by 10 equals, all we're going to do is take away that 0.
Ooh.
Bye-bye 0.
Bye-bye 0.
65736, and then I go over 3 places. To
Stick-
put my comma there, it's 65,736 now.
Nicely done.
With a period, just for Math Dad.
We want to give a special thanks to the patrons who have made this video possible through their support. If you'd like to become a patron and support us, go to patreon.com/sciencemom and join us.
And we have all sorts of links in the description for you, including a link to worksheets that have all the problems we did in this video, plus extra practice problems.
Take the time to practice this. Remember, you're not going to learn it just by watching a video. It takes time and effort to master these things.
Work hard, grow smart. We'll see you next time.